So how do we graph a quadratic function that's in vertex form? We're going to have 3 steps for this process. So in example D, this is vertex form. Step 1, let's first identify the a value and the vertex, which includes the h and k values. So in this first example, I see that a here is going to be a 1. Now I don't see it, but it is a 1 there. So a equals to 1. Now the second that I know that a equals to 1, I know that it's going to be a smiley face. So this is graph is going to open up. So it's going to open up. And if it has this shape, I already know from the very beginning it's going to have a minimum value. So it's going to be a minimum value here because it has a lowest number. So I know that there's no max value here. And I know the shape's going to be an opening up U. Next, I want to identify h and k. So I know h is going to be the number in the parentheses. So h is going to be here, and k is the constant on the outside. Now the tricky part to identifying h is that h is the one variable here that I'm going to identify by identifying the opposite number of what I see. So if I see a plus 3, then my h is going to be a minus 3. And then for k, identifying k is easy, it's just what you see. So here k is negative 2. Now when you guys identify the vertex, this is just a point. Remember that the x-coordinate, or we call h, this is going to represent your symmetry line. So this here is going to be our symmetry. So the second I have that, I can already go to x equals to minus 3 here, and I can draw my symmetry line here, my mirror. So I'll do that now with the same color. So without doing any work, I already know I'm going to have a mirror there. I also know that this point here is going to represent my actual minimum value. So that's your max or min. So my minimum point is going to be negative 3, negative 2. Guys, and that'll be the exact same as the vertex. The vertex itself is going to be your max or min, depending on the shape of the graph. It's where the graph turns. So notice how I've done all this information with only looking at h and k. In fact, here, this is going to be a quadratic function, so I can add that to my details, my description. This is quadratic, again, because it has a square. And then in terms of domain, here I give you domain, so I'll just fill it in for free. It's from negative to positive infinity. So notice how by only identifying h and k, I already have an idea of the shape of my graph. I know where it turns. I know where the mirror is at. And I have all this information about the graph just by identifying h and k. And that's all just step 1 of this process. Step 2 then says, make a table using the vertex as a reference point. So what I'm going to do is make a table, and I'll make it here. So I'll make f, and in this case I'm calling the function f of x. Again, I'm calling it f of x up here in the question. And then I'm going to make here 5 different places for points. And I'm going to use the vertex, which is this point here, as my reference point. So I'm going to put this point in the middle of my table. So negative 3, negative 2. Negative 3 is the x value. Negative 2 is the y value. And I know that this point here is my symmetry point. So it's going to be on this line. So I can think of the table as being cut here with symmetry. All I have to do to finish this graph specifically is you get to choose to pick either 2 points to the right of the vertex or 2 to the left. And you want to always try to go towards 0 because it's easier. So I'm going to here choose negative 2 and negative 1. So I'm going to choose to do these 2 additional points. So to graph this quadratic specifically, all you have to do really is to find 2 new points. So to do that, I need to take x negative 2 and plug it into my function. So I'll do it here on the side. So f of negative 2, and all that requires from me again is to simply copy this function down the exact same way, but leave the x open to, in place, plug in this negative 2. So it's parentheses x plus 3 squared minus 2. So again, I'm copying this the exact same way, but leaving this space open to plug in a number. And in fact, I did the same thing for this negative 1 as well. So I'll just get it set up for you. So f of negative 1 will be the exact same copy where I leave that x space open to be able to input my x's. So now let's try it. If x is negative 2, I'll put that in here and I'll work it out. So what I get here is 3 minus 2 is 1, so I get 1 squared minus 2. 1 squared is 1 minus 2 is negative 1. So f of negative 2 is negative 1. So over here, f of negative 2 is negative 1. So I can fill that number in. And I can finish by finding this other point. So what about when this is a negative 1? So I'll drop that in there. And I work it out. 3 minus 1 is 2. So I get 2 squared. And this minus 2 is still here, so minus 2. 2 squared is 4 minus 2. That equals to 2. So f of negative 1 is 2. F of negative 1 is 2. Guys, if you can do that work, that's all you need to graph this function specifically. Now all we do is we plot these 3 points. Oops. Plot these 3 points, and you'll be done with your parabola. So negative 3, negative 2 is going to be here. Negative 2, negative 1 is here. And negative 1, 2 is here. Once you graph half of this parabola, notice if I connect these points here, do you see that you have half of your u? But because this line has symmetry along this vertical line here, this is your mirror, you can take each point and simply reflect it over that mirror. So this point folds over to here, so I'm going to add that point for free. And then this point, it's 1, 2 away from the mirror, so I'm going to go 1, 2 to find its reflection, so it's there. And all of a sudden, I have my u. So I've graphed this parabola in vertex form.